Welcome back to this class where we are talking about the metals as well as the different compounds of metals. So, now we will be talking about a typical aspects of the metals and their compounds and how we get the metals from a chemist's point of view, or more specifically from an inorganic chemist's point of view, because the industrial demand for metals and their processing and making all these things is the typical engineering aspects people can think of, people can talk of, which is a typical subject for the people who are dealing with metallurgical engineering, who are dealing with materials engineering. And this particular class and the following classes, what we will see about how we look at the metals and their compounds as an inorganic chemist. Because we will be talking about something where we think about the basic and the fundamental inorganic chemistry knowledge will be useful, and that basic and fundamental knowledge of inorganic chemistry, how it is useful for selecting the area of introducing that particular industry where you can get the easy availability of the material for the different types of processing. So, we will start from the lightest metal ion after hydrogen, say. So, hydrogen, helium, and then we have in the periodic table the lithium, because it has a huge demand. So, if you go and ask any particular metallurgical engineer or a metallurgical technologist or a materials engineer, that how you get or how you can start a industry for making lithium ion batteries. So, it is not that you go and start a lithium ion battery and all these things. You should have a very good level of availability and a cheap source of availability of lithium for that particular purpose. If our country does not have that much amount of supply of lithium, we should not think of establishing a company which will be dealing with lithium as your lithium ion batteries. Because if we think that China has a huge source of lithium or any other European country has a huge source of lithium, we cannot compete with them in terms of the price. So, always forget about the fundamental and the academic interest or the academic knowledge. It is the knowledge which will be driven by the market, which will be driven by the economics. So, the source of the material as the corresponding source of the ore or the minerals is important. So, we will look at that and what are the feasibility for the typical or the very simple inorganic chemistry, because everywhere we are talking the knowledge level of our inorganic chemistry, how we can apply to get some useful industry where you can start this for your making this compound of all these things. So, what are those lithium compounds we can have? So, lithium sources we should know, how we can process of those for making lithium metal itself first and then the different compound. That is why the title of this class is the metals and their compounds. So, again we should look at the important material, that means where from we get the huge amount of that thing which is feasible for your industrially possible extraction process is your spodumene, S-P-O-D-U-M-E-N-E is a spodumene. This is the typical name basically. I am not asking you that you should remember it nicely, but so long you have the class, if you as appearing for the exam, you just try to remember it, otherwise how will you know this particular one? Once you know that what is your magnetite, what is your ferrite, from our school days we know that these are the iron sources or the iron materials which is available everywhere, even for our soil sample and everywhere where the soil sample is reddish in color. So, we know that there are hematite, there are magnetite and all these things. So, a geologist can go and try to find out the physical characteristics of this particular mineral. They identify it, they take it, they make it grinding and they go for its typical analysis for its lithium component or any other component. But this particular oxide mineral is a complex one if we now look at the corresponding formula of the material. So, mineral has a formula of 1 lithium, 1 aluminum and 2 silicon. So, is LiAlSi2O6. So, basically is a silicate mineral. So, wherever we find is not that you will get as a free lithium as lithium oxide or lithium chloride, is not possible like that of your sodium or potassium. We will come back once again under the heading of your metals and compounds, the sodium and potassium, but already we have discussed a huge amount of that thing, that how we get sodium chloride, how you get potassium chloride. In the same fashion you will not get lithium chloride. So, always remember that the periodic table goes in a particular direction, and always we look at all these things, and basically we are looking in different categories and in terms of the periodic table also. So, it is basically a silicate mineral. There are large number of silicate minerals we know, and basically the basic formula of this, you can have the bisilicate or disilicate, we call Si2, Si3, Si4, all these more complex materials we have, particularly some useful catalytic material. When we will call at the latter part of our this course, we will find that the zeolites and all these things, which are nothing but silicate as well as aluminum. So, we call them as aluminosilicate. So, this is nothing but you have double silicate structure, that means two silicate ions are there along with one aluminum. So, it is basically aluminosilicate, and aluminosilicate has this particular type of charge when the whole charge is not being neutralized by aluminum or potassium or sodium, because most of these silicates are sodium salts or the potassium salts like our silicic acid and all. It is naturally available as your lithium salt. So, it is not so easy to get that lithium also, because during processing your lithium can go out, can leach from the medium. So, it is very difficult to trap that particular lithium, and lithium has a different characteristics, different inorganic chemistry, and all these things lithium has. So, it is also found together with some other material. One is your lithium mica. So, mica again has a different structure, but it is again silicate. So, silicate structure of mica we can have, and aluminosilicate is there, but there is aluminum are also bound to fluoride as well as hydroxides, like your fluorapatite or hydroxyapatite molecules we all know. But here little bit higher level of lithium, 2 lithium ions are there along with 1 potassium. So, try to look at the formula of lepidolite. It is lepidolite, Lepidolite. So, lepidolite formula will tell you that how nature is giving us this particular rich material, and the way we are getting, people have struggled a lot. Basically, you have 2 or 3 different types of cationic part, because aluminum is within the structure of aluminosilicate, but it is not as a pure cationic form. But you have potassium as the cation, you have lithium as the cation, but that particular salt, this lithium mica, we are not getting as the pure K3 salt, or we are not getting it as the pure Li3 salt. So, whenever we are getting, so nature is also getting this thing, whether it is coming out from the volcanic source or some other sources. Initially it can have a molten thing. The molten thing is basically crystallizing out with time, and during the crystallization, depending upon the availability of your potassium salt nearby or the lithium salt nearby, it is crystallizing as KLi2 sample. KLi2 3 plus, the whole charge is 3 plus with it. So, that particular one, neither Li3 nor K3 is forming, not even K2Li. So, this is the thing that you try to remember this in this fashion, because you have to take this particular material whether it is economically very feasible, economically it is beneficial for isolation of your lithium metal from this particular material. Then we have another one is your pedalite. Pedalite is LiL1, again Si4O10. So, this Si4O10 business is similar to that of your this Si4O10 business of lithium mica, but is of different type because you do not have potassium. Then amligonite. Amligonite is again lithium aluminum only, no potassium, but again 1:1, and all with these your lithium component is not very less, not even very more, it is 4 to 7% of lithium. It is pretty good amount of lithium is available, and you not only get as the mineral from the earth crust, but it can also be available from the different salt lakes. So, the salty water of the lake material can give rise to this particular material. How we get that? So, lithium bearing or the lithium containing brine water, that means the salt water which is coming out from the different salt lakes. Sometimes we get those as the crystallized forms also from those salt lakes as the flakes. Salt flakes are also available. So, those salt flakes also you can have, and you see that nowhere the country which are producing huge amount of this one or the extraction is feasible is only US, Chile, Bolivia and Argentina. Not even the entire US, some pockets always be there, it is the state which is your Utah and the Nevada. So, Utah, Nevada is the place where you can have the corresponding amount of deposition of this particular lithium material, then again other places we can get that. So, lithium during this particular process, the lithium precipitate out as poorly soluble lithium carbonate. So, if you grind it, if you make it in the solubilized form and if you try to get that lithium ion, which is a very small ion, which in presence of water, that means within water, it is always highly solvated, because the solvation power is more in lithium compared to your sodium as well as potassium. So, highly solvated lithium ion you have, and if you try to supply either in the terms of alkaline supply of CO2 or the addition of carbonate, any other carbonate salt. So, what you get that you can have the corresponding precipitate of poorly soluble lithium carbonate. So, you have highly soluble all these things, highly soluble lithium mica or lithium any other aluminosilicate in your hand. So, you grind it, you make it powder, you put water. So, lithium will be leached out from the material, and that material is very difficult to crystallize it. If you think of that, I will crystallize it as lithium chloride, or I will crystallize it as lithium nitrate, or I will crystallize it as lithium sulfate, is not so easy. So, if you just quickly compare the solubility differences of all these lithium salts nicely, you just select, then your natural intention or natural intuition rather will tell you that it is the lithium carbonate which will be very much useful for you to give you the corresponding separation from this material as lithium carbonate. So, we have the lithium carbonate, and how you make that particular one. So, from the ore or the mineral you get the material as lithium carbonate. Now, your condition is that how you get metallic lithium out of it. So, the best way of getting these, like that of your sodium as well as potassium and all other alkali metal ions, we all know you should go for the corresponding electrolytic technique in melt condition, not in solution condition. In solution condition, otherwise you will end up with the electrolysis of water only. So, you get the melt, and for increasing the conductance you add potassium chloride. So, you have a lithium chloride potassium chloride mixture, and at a higher temperature. So, is always not very easy to make, easy to do, is 400 to 460 degrees centigrade in closed chamber in steel cells with a graphite anode and steel cathode. So, two of the material for anode and cathodes are very much specific, because that particular potential only those material can give you the required surface for its removal, that means for its oxidation or for its reduction of the particular material, whether you are talking about the corresponding reduction of M plus, that means Li plus, or the corresponding oxidation of other part to at the other electrode. And the cell voltage is also not very much, it is only 6 to 6.5 volt, and it is formed and collects on the surface of the molten salt electrolyte. So, on the molten salt electrolytes, if you have molten salt electrolyte, you are electrolyzing that molten salt through the insertion of the electrodes, and whatever lithium is forming, that will be floating on the surface of the electrolyte. So, from the surface you can have some exit. If you know the height of that particular surface above the electrolyte, you can have the regular exit channel, and through that exit channel you can take out that particular material for its isolation. Then we think of the typical uses, because you have the ore, you get it as the corresponding electrolytic procedure, and now how you use it, particular one, particularly the metallic one, the metallic lithium. So, one of the most important material that we know from our school days, once again in organic chemistry classes and everywhere, we know that lithium aluminum hydride is a very good reducing agent. And when we talk in terms of the corresponding material as your some lithium mica, lithium aluminum silicate, but it is not so easy to understand it, that there is no procedure available to us still, that whether that one containing both lithium as well as aluminum, to convert it directly to lithium aluminum hydride through the supply of hydrogen gas or any other hydride material or any other hydrogen containing reagent. It is not so easy. So, that way the chemistry process or the process chemistry is completely different. Even the reaction will not go for this particular reaction, but we can think of that your raw material has both lithium and aluminum, and your compound, which is pretty costly. The market has a huge demand. The bigger chemical companies, they are producing for the laboratory use also lithium aluminum hydride. So, we should go to some other ways. That means, you have to convert it to lithium hydride first. That means, this lithium, whatever available as the metallic form of lithium, will be converted to lithium hydride, and luckily we should have some mechanism, we should have some procedure or the industrial technique where the lithium metal can be converted to lithium hydride. Then we can have like potassium amide KNH2, we can have LiNH2. These are very useful reagent for organic transformations, pharmaceutical industries, any other industries, and for the synthesis of any other organolithium compounds. So, organolithium compounds we all know, these are organometallic compounds, and most of the organometallic compounds we all know, like your Grignard reagent, which is a organomagnesium compound. We also study from our school days that organomagnesium compound, what you can have, that particular organomagnesium compound is useful for some good techniques. Similarly, the corresponding organolithium compound, even the methyl lithium, if we consider that LiMe. So, methyl lithium type of thing can be the very useful organolithium compounds, and sometimes these organolithium or some other modified compounds are also useful in as catalyst. Why you are making a very small compound of all these things? If you require certain amount of bulk, industrial we are producing several tons we are producing, but if we require only a small amount of this for the laboratory purpose, for your drug making business or the pharmaceutical industry or the perfume industry or the food industry, what you can think of that the consumption for the laboratory use definitely of a high grade analytical reagent or the guaranteed reagent form, your consumption is more, but your value addition is more and more compared to your bulk material of lithium or lithium metal. But if you move from that material for day to day laboratory use or the industrial laboratory use also, industrial R&D use also, you can go for the making this as the useful catalyst, because the catalyst requirement very small amount, only some milligram scale, sometime it can go to nanogram scale also, but it is a catalyst which is not changed after the reaction also. So, it is unchanged after the reaction also. So, in the polymerization reaction, so the whole polymerization industry, the polymer industries basically will be dependent on some of these lithium bearing compounds, because if you have very useful organolithium compound can serve as a catalyst, which you cannot get from your corresponding organosodium or organopotassium or organotransition metal compound. As I told you that it is a very useful one as lithium aluminum hydride LaH making. So, is a reducing agent in organic chemistry and also in refining of metal melts in metallurgy. So, when you use these as reducing agents, so in the refining industry also, in the metallurgical industry already we are talking all the time that how you handle the metal by a metallurgical engineer. So, in metal melts in the metallurgy we use also the lithium for its regular supply. Then another useful important application is making of lithium, as I told you that organolithium compound, but it can be incorporated in alloy making also, because these are very useful compounds. The way we say that when we talk in terms of, when we will be talking in terms of your transition metal ions, say palladium and platinum, when we are talking about the corresponding diesel exhaust, the NOx removal, we have seen that also we can have the catalytic converter, and those catalytic converters are only on very precious metals like palladium, like platinum, like iridium, like rhodium. But lithium is not so costly, because we are using, we have started using, we are still using the lithium ion batteries. And if you have the magnesium, so the lithium magnesium alloys, magnesium is a very lighter element, lithium is also very lighter one, but individually their characters are different. But when you go for making this corresponding alloy of lithium magnesium, you get a new product or new alloy material which can find a very useful application in aerospace industry, because is very lighter one. So, for making aircraft components and other things, such that in a lighter way, that means your things should not be heavy. Even if you make a motor, even if you make a window, even if you make some structure, you can use this because the lighter one. So, aerospace industry is very much dependent on this sort of alloy, and people are also working on it, how we can improve the corresponding alloying nature by using some other third metal ion or metal center for alloying process, or improving the corresponding composition or the process. It is also very much useful or very much applicable for nuclear application also, while we make nuclear weapons manufacturing, because if it is not very much destructive one, and if it is highly resistant for all the different types of nuclear reactions, that means neutron bombardment, gamma bombardment, alpha particle bombardment. So, if it is had the typical resistance, we can use it in nuclear technology. And the thing what we are talking in terms of its making the lithium batteries, it is functioning as an anode. So, making these batteries as the anode material with a high energy density, because these are the typical characteristics when people are working on, the electrical engineers are working, then others, the energy engineering is another branch of engineering, because we are having shortage of the fossil fuels. That means the coal is limited, the oil is limited, and many other things. The solar cell also does not have that much applicability. So, we can go for all these things, that means the lithium ion bearing batteries and high energy density and long term stability. It is stable because you can use it for several years, that is also very important. So, these two components, high energy density and long term stability of the lithium metal, makes this very useful material for giving you the lithium ion based batteries. So, that is again a huge area. If you are interested, you can read it, you can also learn it, that how only that one particular metal ion, which we know that how we can get it, starting from your ore material, starting from your minerals, starting from your lithium metal, to get that particular lithium ion batteries. Now, we will, like that of your lithium aluminum hydride, what other lithium compounds we can have, but most importantly those are lithium carbonate, lithium hydroxide. Already I told you how you get the lithium hydride, and lithium chloride, the chloride salts, always very much useful. The first one, how we make it and how we get it, we should start from spodumene again. So, the calcined spodumene, that means is heated, and you have the corresponding breaking and making the powder of this thing. So, enriched material or enriched mineral, what we call it as the enrichment in terms of the corresponding lithium percentage, then is digested with concentrated sulfuric acid. So, sulfuric acid is needed. So, concentrated high sulfuric acid, which is highly corrosive one. So, we will basically break the corresponding mica structure or corresponding aluminosilicate structure in the spodumene, and whatever inert material as its anionic part was there. Only idea is that in acidic medium we should take out that particular lithium from there as the corresponding lithium ion. So, a high temperature is also applied. So, it is a high temperature reaction. So, it is basically leached with water and finally reacted with sodium carbonate. So, lithium is taken away through this particular procedure and taking of that particular lithium from that material is next is used for its reaction with sodium carbonate, because the sodium carbonate reaction will give you directly your lithium carbonate formation. So, this particular lithium carbonate, if you make, that lithium carbonate has huge application in different areas, is for aluminum manufacture. So, manufacturing of aluminum is also dependent, because sometimes it is the ingredient for aluminum production from bauxite, then glass making, then enamel, ceramic industries, and the medicine also, because small amount of lithium can help as a medicine also, because the neurodegenerative problem or the bipolar problem, people have started using this one. But we should not forget something, that historically this particular material, the lithium carbonate, is functioning as a medicine, and we are using say 100 years back or 75 years back. Now it has been discontinued, because we find that it can have certain disadvantages, certain side reactions, and it is maybe harmful for some other organs of our life. But you should know historically that how these molecules, that means the small lithium center, the lithium ion is useful. When we know that we have in our body the corresponding channels of sodium as well as potassium, whether that is hampering that, or the signals, the neurosignals in our brain is governed by corresponding ion potential of that different gradient of sodium and potassium, whether those are affected by lithium. So, the traditional knowledge is useful. You may not apply it for industrial production of lithium, but future application and all these things are required. So, your knowledge base should be very high. It is not that the material what is needed to know is for huge production and which has a huge demand in the market. You may not know that the basic or the academic interest of all these things can have some future application. So, like that of your lithium, which was present in your lithium mica or lithium aluminum silicate, that also tells you that nature is accumulating that particular mica or the material with a lithium as its component. So, why not synthetically, when we make or when we produce glass, when we make enamel and when we make ceramic, why we should not incorporate lithium? That means lithium has some role definitely to play to improve the corresponding properties of this thing. Similarly, lithium hydroxide from carbonate, directly we know the inorganic chemical reaction. So, inorganic chemical reaction will tell you how quickly you can make lithium hydroxide. So, again, from your knowledge sake, from your query sake, from your question sake, what you should know that what are the materials. If I ask you how lithium hydroxide can be prepared from a useful material or useful lithium compound, and your choices are given. So, the right compound for this reaction is your lithium carbonate. And why you use calcium hydroxide, why you are not using other hydroxides also, that you should ask yourself. So, you have a very standardized reaction which is known for the 100 or 200 years, and how you can lead that particular reaction for industrial production, such that always you think of whenever you write A and B for a particular type of reaction, why we are not thinking the other hydroxides, why we are not thinking about the other carbonate materials or other lithium material for its production. So, industrially this particular one is important in the manufacture of greases, oil based thing, which is nothing but your lithium stearate. Stearate is the long organic molecule we all know. So, that organic molecule when gives you the corresponding lithium salt, not the sodium salt, because the sodium palmitate, sodium stearate, we know the common household soap. When it is lithium, it is the thick one and it is the greasy material which is industrially very important. Then lithium hydride, from the direct reaction of your lithium and hydrogen, can be obtained at a very high temperature, say 700 degrees centigrade. You have a direct reaction of lithium with hydrogen giving you lithium hydride, which will be utilized for making your lithium aluminum hydride as well. So, getting this lithium hydride is very important, and that lithium hydride for the production of lithium aluminum hydride is also very important. So, it is an important source of hydrogen as a reducing agent in organic synthesis. So, directly either lithium hydride you use or you convert it to lithium aluminum hydride, because it is very easy to use is very user friendly also, because lithium hydride storing of the material in the laboratory, storing of the laboratory in the material in the industrial sector is also very difficult. So, its shelf life we call, how long you can keep in the laboratory shelf, how can you can keep in the laboratory cupboard. So, that is also very important, because the day you purchase, within next 7 days you are not consuming the whole material. That is why it gives stability compared to your lithium hydride to make or convert it to lithium aluminum hydride. So, we will continue in our next class that how we can finish this lithium and any other useful metal centers or the metal ions and their useful compounds. Okay. Thank you very much.